morning, class. We are Team 19. My name is Rodolfo Guerrero.
My name is Alfonso Jarquin.
My name is Pedro Chapiano.
And we are here presenting the Boeing 787 Dreamliner. I'll first be talking about the introduction of the aircraft, as well as its history and the cost analysis. The 787 is actually Boeing's latest commercial aircraft. It is also Boeing's most fuel-efficient aircraft that they have manufactured right now. And it is driven with the next generation technology, which is the reason why it makes it the most fuel-efficient aircraft. The exterior of this aircraft is actually made of composite material, which is way more durable to impacts, and it's much better than the aluminum alloy that they used to make the aircraft before. The aircraft flies on electrical flight systems, which are way better than the mechanical flight system that they used to manufacture these aircraft with, because the electrical flight systems are much lighter, making the aircraft more fuel efficient. The 787 actually has 4 different models. The first one was the 787-3. During the production phase, the Boeing approached many problems, and because of that, they had to discard that aircraft. And while they had those problems, they actually came up with the 787-8, which after that, they came out with the 787-9, and as of right now, they're working on the design phase for the 787-10. Okay? Before the 787, Boeing was actually working on a project called the Sonic Cruiser. This aircraft was very fast and could reach a cruising speed of Mach 0.95, which is around 746 miles per hour. But because it was so fast, the aircraft was not very fuel efficient. And as we all know, 9/11 happened, and that took a drastic hit to the airline industry. Because of that, fuel costs rose, and the airline companies were in demand for a more fuel-efficient aircraft. Since they wanted more fuel-efficient aircraft, Boeing was like, we're going to discard the Sonic Cruiser, and we're going to come up with the 787, which is a more fuel-efficient aircraft. Since the 787 is more fuel-efficient, the aircraft can only reach a Mach 0.85 cruising speed, which is around 645 miles per hour. Also, the 787 was actually named the 7E7, where the E stood for efficiency. Right here, we have a picture of the first class of the 787. Right here, you can actually see how they're trying to make the aircraft more modern. But because they're trying to make it more modern, the manufacturing is very costly. Boeing actually loses $26 million for every 787 that they manufacture. Also, because of that, they have to raise the prices to $225 to $305 million for each aircraft that they sell. Analysis also talked about how Boeing has a very non-profitable aircraft for the 787, and they said that they will probably make profit after a couple of years of having this 787.
Good morning, class. I'll be talking to you about the 787's design and production and prototyping phases of its production. Now, the first thing that we can characterize the 787's design by are its raked wings. Now, these raked wings actually have a steeper sweep angle, which is pretty much like the taper angle of the wing. This thinner taper at the end compared to the larger taper angle at the front increase the wing's aspect ratio exponentially. Now, this aspect ratio is a ratio between the wing's length versus its width. A greater aspect ratio means greater lift, which means a greater reduction in drag, and means a greater fuel efficiency. Now, this wing also has a slight upward angle, much like a winglet. This winglet, like the signature L that you are all familiar seeing on such things like maybe even like next generation aircraft, actually are about 4% efficient when it comes to reducing drag. Now, this newer angle actually increases that efficiency to 6%, which means a greater reduction in lift-reduced drag, which is pretty much a natural phenomenon where a vortice is formed behind the wingtip, decreasing its lift. Now, this can be very dangerous, of course, because it can cause turbulence on the aircraft, but Boeing has figured out a way to reduce this greatly while increasing the fuel efficiency of the aircraft. Now, the next thing that can characterize the 787's design phase would be the seating capacity and its range. The 787-8, which is pretty much like the base model of the Dreamliner, can have a range of about 8.5 thousand miles. But the 787-9 has a range of about 9,000 miles. That's 500 miles more than the 787-8 model. Now, this comes at a sacrifice, of course. It actually has a smaller seating capacity, but is a little bit more fuel efficient and can travel a farther range. Now, the next thing that will categorize the 787 Dreamliner are its two massive engines, each of which is able to produce an average of about 65,000 pounds of thrust. Together, that's 130,000 pounds of thrust, and that is only the amount required to get it off of the ground. Now, I have listed here two engine models, the first of which is the General Electric Gen X, and the second, the Rolls-Royce Trent 1000. The Trent 1000 was the initial engine that Boeing was going to go with, but it suffered severe freezing problems at around 4,000 feet, which Boeing decided not to go with because, of course, that's extremely dangerous. This occurred in the initial testing phases, so the problem was resolved, and Boeing came to General Electric, which produced the Gen X engine. Now, this Gen X engine is extremely fuel efficient because of the fact that it had done away with the bleed air systems. The bleed air systems are pretty much air taken before the combustion phase, which will be right around here, and it uses that air for environmental control systems, pretty much air conditioning. Now, this engine doesn't do that. It actually takes the high temperature and high pressure air to power those systems themselves, as well as auxiliary systems on the aircraft. Now, another thing that can characterize the 787 are its extremely fuel efficient hybrid laminar flow control systems. Now, this control system is actually just thousands of tiny perforations which occur right along here on the vertical stabilizer. These tiny perforations act much like a golf ball, smoothing the airflow around the wing, therefore reducing drag, making it more fuel efficient in the end. This airplane is all about fuel efficiency. The next thing that can characterize this plane, which is actually the biggest thing about it, is the fact that it is made of mostly composite materials, which is a special carbon fiber plastic which Boeing manufactures. Now, this covers the majority of the fuselage and the wings, which is extremely light, making the aircraft more fuel efficient because there's less load required to move the plane. But what's actually really impressive are the titanium alloys which run along the leading edges of almost all of the areas. This titanium alloy is extremely thermal resistive, which is very good because it reduces things like air friction, which can be seen in extreme effect on things like space shuttle. You can see this can be very detrimental to the aircraft's lifespan and as well as its fuel efficiency. Again, I cannot stress that enough. Now, the Dreamliner came with 10 prototypes, 7 of which for the 787-8, its base model, and 3 of which for the 787-9. The 787-8 were actually called the ZA series planes, which is the first picture. The ZB series planes, the second picture, were the 787-9. Now, the ZA series planes had a testing phase from December 2009 to February 2011. Now, this is almost a year and a half of testing, which is a long time to get the plane approved by the FAA. Now, the ZB series, the 787-9, which is actually about 20 feet longer than the ZA series, took only a couple of months to get approved. That's from September 2013 to January 2014. And although it had a shorter testing period, it's actually the one with the least amount of problems. The 787-8, or the ZA series, actually suffered severe icing with the Trent 1000 engine, which they recovered with the Gen X. But it actually had some electrical fires during its testing, as well as battery failures, as well as windscreen cracks during its testing phase. Now, these planes are able to fly of a cruising speed at about Mach 0.85, which is about 640 miles per hour. Now, that's not extremely fast, but it does mean that these planes can go where they're going at a nice rate, but they can go very, very, very far. Thank you.
I will be covering global design, assembly and disassembly, and ethical responsibility. Boeing is the world's leading aerospace company, and it's the largest manufacturer of commercial jetliners and military aircraft combined. And now they are involved in global manufacturing and delivery process for the first time in Boeing's history. More than 100 partners across 12 countries and 5 continents. The goal of global partners was to reduce the cost, speed time to market, and increase customer value while maintaining the highest level of safety. This is the network, as you can tell. The challenges were maintaining control of global partner model to provide best value of components and technology. Boeing turned to X-Star to manage process of the supply network. One example of the newly developed technology that the AIT created for the Dreamliner assembly and disassembly was the full circumferential and automated drilling machine to join the structures delivered from the global partnership. As you can see, this is the circular drill, and this is in assembly and disassembly process. The advantage of this was to improve the quality of precision with laser tracking, joining components. It replaced large labor-intensive crane system and reduced the labor costs as well as speed up assembly line process. Even with Boeing safety regulation, ethical responsibility was not implemented in the 787. There has been noted of several pre-launch issues as well as post-launch issues with the Boeing 787 Dreamliner. They have been linked to issues with assembly and manufacturing of quality management flaws, but the two most considerable malfunctions of the 787 were the battery fires. Insufficient testing and poor understanding of the innovative battery all contributed to the grounding of the Boeing 787. The solution was fixed with the internal components of the lithium-ion battery and sealed the battery in a steel-sealed box. As you can tell from this diagram, this is the structure of the battery and the outside layers of the steel box. The problem was that the company merged with competitor company McDonnell Douglas in 1997. Their new business model was more concerned with the profit of the company than the professional and ethical responsibility that the former management works hard to build through the former years. But the decision cost more money in the end to reverse all the issues that would not have been there in the former safety guidelines. Boeing shortchanged the engineering process to a schedule and not allowed quality control to do their job, putting lives at risk, leading to poor quality and integrity. Boeing has since increased supply chain support to assist struggling suppliers. Identifying realistic risk factors and the required supplies to follow industry standards to ensure similar errors are not repeated in the future. That's our Boeing 787 project. Thanks for watching and hope you enjoyed.